Okay, so we ran out just before we finished question number 35. We ran out of video time. So we were at the fact that we had just found V3 was 54 volts. It's a parallel circuit, so in parallel all voltage is the same, which means V total is 54 volts, V1 is 54 volts, and V2 is 54 volts. And so now you can find R2, R1, and R total by dividing the 4.8 into the 54 for each one. So 54, well, you can do that. I don't know what they are. Let's see. I might be able to find them if I looked hard enough somewhere. Anyway, yeah, you can do it. Just finish the rest, okay? Because we need to move on to more important things, which is complex circuits. So on a sheet that you have an example of a complex circuit. If you look at this example, you'll discover that it has both series and parallel parts. Now, the other day in class, I may have lied to you just a little. Well, not really lied. I just didn't tell you the full truth. Because I had said all the circuits in your house were either series or parallel. In truth, there are circuits in your house that are a combination of series and parallel. So part is parallel and part is series. If, if you look at this guy, you might be able to understand what I mean. Because all of the current would leave the power supply, assuming it's electron current, and it will flow this way. And when it gets here, it splits. And so some of it will go through this resistor, and some will go through this lower one. Then it will come back together, and then it'll flow up here and go through the resistor up top. Okay? I've drawn the same circuit, just a little bit differently. Here it is here. And I turn my power supply around to it so that it matches the R1 and the R2. So all of my current leaves the negative and it flows through R1. So that means it's in series with R1. And then it keeps going, but when it gets to this point, there's a junction and it splits, which means R2 and R3 must be in parallel, just like they were here. The current split, so it means these two, R2 and R3, must be in parallel. Whereas this one has the total current, which means it's in series. Okay? So I2 flows through R2, I3 flows through R3, and when they get to the bottom down here, they come back together and the total goes back to the battery. Okay? So now the bad news is our equations don't work for a complex circuit. Instead, we have to simplify it and make it either a pure series or a pure parallel. So how do we do that? Well, we look at the circuit and we say, what resistors can we take out here and replace with a single resistor that would make this either a complete series or a complete parallel? If you take a look, I'm hoping you will be able to see that if we removed R2 and R3 and replaced it with a single resistor, then we would have a circuit that would still have R1 up here, but now instead of a branch for R2 and R3, we would have a resistor, this one's R1, that we would call R23. And R23 has to be the equivalent resistor to R2 and R3 in parallel. So R1 isn't going to change, it's still going to be the 8 ohms, and I'm using the numbers of the example on your sheet. Okay? And R3 is 6 ohms, R2 is 3 ohms, they're connected in parallel. So I can find my R23 by doing 1 over R23 is equal to 1 over R2 plus 1 over R3 because they're in parallel. So that means 1 over R23 is equal to 1 over 3 ohms plus 1 over 6 ohms. Common denominator is just going to be 6, so 2 over 6 plus 1 over 6 is 3 over 6. So R23 is equal to 3 over 6 ohms, or 1/2 ohm. So R23 is equal to 2 ohms. Okay? So I've solved R23 But better than that, if I look at my circuit now, I will see that it's a complete series circuit. So I've simplified it enough that now I'm going to be able to solve it. So my next step then is to build my chart. So in my chart, I need a V total column, a V1 column, a V2 column, a V3 column, and a V23 column. So I need a column for the equivalent resistor that I've replaced R2 and R3 with. Okay, so if you want to take a second, pause me and build your chart and then turn me back on. Okay, so now once you have your chart built, we're going to put in our givens. So we're given that the total voltage is 120 volts. We're given R1 is 8 ohms. We're given R2 is 3 ohms. We're given R3 is 6 ohms. And we just found that R23 is 2 ohms. So we have our chart. I might just need to back it up a little so you can see the whole thing. So we have our chart. And if you look in the R column, we have everything except our total, which means we can find our total. But be careful. Our most simplified circuit is series circuit. And in a series circuit, you can just add up the R's. But please don't add up R1 plus R2 plus R3 plus R23. That's not what is in series. What's in series is what you have here in your last diagram, R1 and R23. So you add those. 2 ohms and 8 ohms gives you 10 ohms, and we put that in our total. Okay, so now that you have our total, we can now find I total, 120 divided by 10, 12 amps. And then you look at your most simplified circuit again, and you say it's in series. And in series, what's the same? The answer is current, which means I1 will be equal to I23 will be equal to I total. Please don't get 12 amp happy and put 12 amps in every spot in all the I's because you say, oh, it's in series. Because the only ones that are in series are R1 and R23. So they're the ones that have the same current as the 12 amps. So where I1 is, put 12 amps, and where I23 is, put 12 amps. Now that you have those, you can get your volts. So V23 has to be 24 volts, and V1 has to be 96 volts. And these two should add together to give me back my 120, and they do. Okay, so we've now finished our most simplified circuit. Okay, but we still have 2 and 3 to solve for. So now we need to step back to our unsimplified circuit. And we need to say, well, R2 and R3 were in parallel, and they were replaced with R23. So in parallel, we know voltage is the same. So that means V2 and V3 should be equal to each other. The question is, equal to each other and equal to what? Are they going to be equal to the 120 volts? I hope not, because R1's taking out 96. So when the electrons flow through R1, they lose 96 volts, and then when they get here, they only have 24 volts left, no matter which way they go through. So R2 has to be equal to R3, has to be equal to what you found for R23, which was 24 volts. So put your 24 volts in here, your 24 volts in here, and now you can find your I's. 24 divided by 3, that's 8 amps. 24 divided by 6, that's 4 amps. These two should add together to give me this 12 because in parallel the current adds up, and it does. And so we're finished. We finished our chart. We found everything in the circuit. All is good. Okay? So let's start a second one. The second one is going to look like this. So it has a 120 volt power supply. Let me make it bigger before the video dies. R1 is 8 ohms. R2 is 9 ohms. R3 is 18 ohms. R4 is 4 ohms. And R5 is 8 ohms. Okay? Now the video is going to run out in 2 seconds here. So after you draw this, see if you can simplify it. And then at the start of the next video, I will simplify it and solve it with you.